Hello, so in this mini lecture we're going to convert between base 10 and other bases as well as other bases to base 10. For starters, let's note that in our system we use base 10. Meaning all of our place values are powers of 10. We have ones, tens, hundreds, thousands, 10,000s, and so on. Well, and note that it's called base 10 because our base in each of these are 10. If we have something like this example where we have base 5, well, now our place values, instead of being powers of 10, are powers of 5. I'm going to show you two different approaches to doing this. So let's write out our number. So one approach is just noting that when we have our place value, we have a 4 in the ones place, but that'll be 5 to the 0. We have a 1 in the fives place. We have a 3 in the 25's place, and then a 2 in a 5 hue, or in other words, 125 place. And then we use order of operations to compute this. Exponents first. And then products. And altogether we end up with 334. So 2314 base 5 is the same as 334 in our system. A more visual approach, if you're more of a visual person, put each number in boxes. And think of it like a cash register where we have different denominations of bills rather than ones, fives, tens, 20s, and so on. Imagine we have instead our ones bills, fives, our $25 bills, and $125 bills. Well, if we have 4 ones, then we have $4. If we have one $5 bill, then I have $5. If I have 3 $25 bills, I have $75. And finally, if I have 2 $125 bills, I have $250. And altogether, again, you have 334. Either way, you get the same answer, but some prefer this method. Next, we're going to go backwards now. I want to convert from our system, base 10, to first let's do base 8, and then base 16. So for A, there's two ways of going about this. Your book shows you successive divisions, and there is an alternative way that they show. I'm going to go with the alternative way on account that with the Babylonian and Mayan system, you have no choice, you have to do it that way. So, here's what we're going to do. I want to know how many place values do I even need. It's not necessarily 4, I'm not sure how many I'll need. So to do that, I want to start write out powers of 8 until we go over. Think of it like the Price is Right. So 1, 8, 8 squared is 64. 8 to the third is 512. 8 to the fourth is 4,096. After that, we're going to end up going over 5,821. So we can stop there. This tells us we have 5 place values. So I'm going to represent that with 5 boxes as our final answer. Okay, so as far as this goes, now I'm filling the cash register. It's more or less the same as making change. I want to know how many 4,096s go into 5,821. So it only goes in once. 1 times 4,096 is itself. We subtract, we get 1725. So, important part is, that goes here. Our quotient goes in the boxes. Next, I want to know, with the $1725 that we have left, how many 512 bills do I need? And if you're using your calculator, you'll see that you get 3 point something. All I want is a 3. So now with your calculator, you do 3 times 512, and we get 1536. Subtract off, we get remainder 189. Again, as we're doing this, fill in the quotients. And on we go. Now I want to know how many 64s go to 189. 2 point something. Well, 2 times 64 is 128. We subtract, and we get 61. And we keep going. Now I want to know how many 8s go into 61. 7. And we have remainder 5. Okay, and finally it's a silly question, but we have to do it for completeness. How many 1s go into 5? Obviously 5. 5 times 1 is 5, and we're left with nothing. So that makes our final answer $13275 base 8. So in other words, 5,821 is 13275 base 8. Okay, I'm going to clear this in order to have room for part B. So pause the video if you would like. Okay, so now we would like to convert 5,821 to base 16. Note that in base 16, our digits go from 0, 1, 2, all the way up to 9, but really we have to keep going because we should be having digits between 0 and 15, since you always go one less than whatever your base is. The only problem is, I don't want to write 10 and 11 and 12 and 13, 14, 15, because this could be very ambiguous. If I write a number like that, it's really ambiguous as to how many place values did I really mean. Did I mean that there's an 11 here, a 12 here, and a 5? That there's 3 place values? Or did I actually mean them all separately? So there's 5 place values or somewhere in between. So to get around this, we write everything above 9 as a letter, so that way it's technically a single digit. And we just start with A and go up as high as we need to, though we typically will stick to base 12 and base 16. But in any case, let's get started. So first I need to write out powers of 16 without going over 5,821. So 16 to the first, 16 to the 0 power is 1, 16 to the first is 16, 16 squared is 256, and 16 to the fourth is 4,096. Anything higher than that will be higher than 5,821, so we don't do that. Okay, so now we're going to start dividing. I know I'm going to need 4 places. For our final answer. So we begin dividing now. I want to know how many 4,096s go to 5,821. And we know from before it's 1725 with the remainder. I want to put the 1 there in our 4,996 place. And we go on and on with this. How many 256s go into 1725? Well, 6 point something. So I want to write 6. 6 times 256 is 1536. We subtract it, we get 189. Put a 6 here. And now I want to know how many 16s go to 189. 11. Well, 11 point something. So 11 times 16 is 176. Instead of writing 11 in here, remember, we want to write the letter version, so I'm going to write B instead. So we want to take our remainder here. Our remainder is 13. And finally, we want to know how many 1s go into 13. 13 with remainder 0. Again, instead of writing 13, I want to write D instead. So that makes our answer 5,821 is 16BD base 16.